Hello, my people, my babies, and my bubbles. How are you? Hope you are doing great. Now, this class today, we want start our normal classes where we dey do. Before, I know the ones wey we don't teach. This one na different one. Now we wan learn. Now, for the sake of say we dey do different ones, we go give this one wey we wan do, the different one we wan do today, we go give am new code so that when you see am you go know say this one na different one. The code wey we go give this one na MTH 102. This one na the code wey we go give these ones dem wey we wan teach. Now, inside MTH 102, wetin we wan learn? The thing wey we wan really learn, the name na calculus. Calculus na im be the thing wey we wan learn. Now, if we wan learn calculus, plenty things dey wey we go achieve, wey we go learn put for body, wey go make us say we don learn calculus. Now, wetin be that calculus? Anytime wey we talk about calculus, the main things dem wey follow am na differentiation and integration. How to differentiate something and how to integrate something. Na im be the thing wey follow calculus. But before we go learn those things, some things dem dey wey go enable us make we prepare the ground well so that when we wan do the differentiation and integration, we go really understand wetin dem be. Now, wetin be those things dem wey dey? I go just write dem out so that we go dey look dem one by follow, small dey go. Now, if we wan really learn this calculus, meaning say we go learn things like this. One of them na dem call am function of a real variable. Function of a real variable. That one na one. Now, this one wey dey very important well o. E dey very important well because this one na im dey like the bed wey this calculus dey sleep on top. So if this one you no lie am well, you no prepare this one well, the calculus no go fit lie down well. So this function wey we dey talk about, e dey very important. Now, inside function, we go learn things like when dem say function dey injective, that one na big grammar o, gbege don come. Injective. When dem say function dey injective function. Now, another one wey we go learn inside now, when dem say function dey surjective. Another one dey again, dem plenty small o. The other one na when dem say function dey bijective. All these ones dem wey dey here, wetin I dey try to write na function o. This function na I dey try to write, but na shorthand na I dey use so that we no go dey write plenty things. Now, these things we go learn am, wetin dem mean when e dey talk about function. Then after that one, other things dem also dey wey we go learn. One of them na say algebraic combination of functions. Say how we go carry this function wey we dey talk about, how we go dey use add am together, how we go dey use minus am together, how we go dey use times dem. If function dey here, function dey here, how we go dey use do, minus, add and to subtract dem, that kind thing. For English dem dey call am algebraic combination of functions, algebraic combination of functions. Now they call that one. Now, as we dey look this one, another one day where we go learn again too. That one we call them piecewise functions. Piecewise functions. Now, these piecewise functions, now function na something wey sometimes e dey like one long group, but this piecewise function you go dey see am small 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 small. This one small function dey somewhere and that small one dey somewhere. When we dey learn dey go, una go see as e be too. This one sef dey very very important. Another one dey wey dem dey call even and odd functions. When they say function dey even, and which one you go come say function dey odd, we go learn am here. Even ones, those ones wey you go use divide by 2, wey something no go remain. Odd one na something wey if you use share into 2 people, something go remain. So when you see feel say function dey in this one, when you feel say another function dey in this one, when we don enter am, we go really understand wetin we dey try to talk. Another one dey wey we go learn, that one na composition of functions. Composition of functions. This one na when function dem dey together, how we go use rewrite them, how we go use arrange them, how we go use write am well. If e dey one kind, how we go fit use arrange am, na we go learn inside there. And this one sef, e dey very important. E dey very important. After this one, we go learn another one. That one na they call am inverse. Inverse functions. Now, this inverse function, we go learn how this function wey we dey talk about, when e dey under something, when e dey under, the other ones dem maybe dem just dey on their own. But this one wey we dey talk about, when dem dey under, how e go look like. When we don know wetin function dem be, we go come begin to dey keep am for different way so that we go understand wetin dem dey talk. After that one, we will come talk about limits and continuity of a function. Limits and continuity of a function. For this very one wey we see so, we go dey look how when something don dey near something well, if like we wan touch this wall, when e don near am well, wetin dey happen to am? When something don dey near something well, wetin dey happen? Either from back side or from front side, when you don near am well, but you no really touch am, but you don really near am well, how e dey happen? We go learn that kind thing inside here. After that one, we go come learn another one wey the main things dem as the topic write am say calculus. Those main things dem, that one na differentiation. Differentiation. Then the last one wey we go learn for this course wey we don open so na integration. Now, all these things wey we don put so, na we go learn one by follow, so that we go go understand the thing wey dem dey call calculus. Na so we go use learn am. Now I don show una the things dem wey we go learn inside, make we now begin to dey touch them one by follow. So we go start with this one. Wetin this thing really mean wey dem say na function of a real variable? Wetin dem dey really talk? Make we talk something inside so that we sef we go understand wetin dem dey talk. When person say na function of a real variable, wetin e really mean? Wetin e really mean when dem say function of a real variable? Wetin e really mean? Now, this thing wey dem dey call function, e dey very important well well when e don dey do with human being. All the bukuru houses wey dem dey call the things dem wey people dey learn, inside there sef e dey very important. You wan talk about mathematics, e dey very important for mathematics. For physics too, e dey very important. Those people wey dey do engineering too, e dey very very important. People wey do doctor and nursing, dem sef, wey dem dey call medicine, e dey very important for things like that. Anything wey you dey do for life, this thing wey dem dey call function, e dey very very important. Now, make I talk something. This function, already I don talk am before, but I dey talk am again. Say this function, say na im dey like the bed wey person dey arrange to sleep for this calculus. For differentiation and integration, for you to learn those things well well, this function of a thing go really dey. E dey very very important. E dey very very important. Now, wetin dem dey really say function be? If e dey very important, wetin dem say function be? Now, we dey say function, make I write am for English so that I go explain am well well for us to understand, or for una to understand. Say a function is, in mathematics, is a rule or relation that takes x values into itself and attributes y values or f of x values in a 1-to-1 correspondence. Now, this one, I write am for English so that we go fit see am well well. Now, wetin this one mean? Say, this thing wey dem dey call function, say e dey like something wey dey somewhere, wey go take some things wey dem dey call x, numbers, things wey this side dey this side, e go take am, e go come put am for himself. When e don shake him body well well, e go come carry am out. Now, example of wetin I dey talk now, human being as you dey, na you be the relation wey we dey talk about. Say im be relation. Say human being you be relation. You carry garri from this side, put for your mouth, you eat. The body come adjust am well well, come digest am. You come bring out wetin again? You come bring out shit, that kind of thing. So the x value, say you go take am. So if you take am like food wey you don take, put for yourself, then when you don shake your body, you come bring am out. Like if you drink water too, the next thing for sweat or for another thing. So this one now, when you bring something put inside, e go come arrange am well, then bring am for another thing. Na im be the thing wey we dey try to say. If dey take x values, this one now we just dey use am dey demonstrate something, x values, into itself, put for your body, then e go come attribute, means e go come bring out another things the way that they call y value. You know say when this one don't enter inside, when the x value don't enter inside the body, when you don't process and when you don't do it, it don't change. When hot water don't touch the garden no gon dey dry again, it don't wet. The way that one gon dey now gon dey different. You understand me? Now make I write am in a way we go fit understand am again. Make I draw am small. If I say we get something like this one na im be the relation. The relation we dey talk na something like maybe small mathematics wey dey. This one na im we dey call relation. Small mathematics. Say he dey take something put for himself, and that thing we dey call am x values. X values. And sometimes we dey call them input values. Input values. Then when he don shake him body well, he go come do am, process am, he go come outside. Then this one now he go come call am output value. Or you call am y values. So you go come process am, when you don put the thing inside, you go come outside. Now this kind of thing na dem say relation be. And it dey very, very important. Now, this thing that we dey talk now, mathematics, na we dey mathematics grammar, na we dey speak here. So now make I call that small mathematics to use explain this thing wey we dey talk. Now, before I write the mathematics sef, I fit use myself again to use explain, make we understand. Now see, but before I use myself, make I write the mathematics. I think na mathematics we wan learn. Or yeah, make I write am so that we go understand wetin I dey try to talk. Now, the relation make we say, for example, make we say f of x be equal to 2x plus 5, where they say x, say they take value, they take number inside this place. X fit take minus 2. This one na number. Minus 2, minus 1, 0, 1, and 2. Na im dey inside this place. Say x fit take any number. Now, this side means x is a f is a function of x. Now the grammar wey dey for here say f is a function of x. Now the meaning say f wey dey, this one wey dey here, say e no go fit dey on im own. Say him dey rely on, him dey rest on this other one wey dey inside wey be x. Say without that x, say f no go fit dey. So for mathematics, when we dey learn mathematics, this one we dey call am, because say e no fit dey on im own, this one we dey call am dependent variable. Say e dey depend, e dey rely on. So if e dey rely on this one, meaning this one fit dey without this one, but this one no go fit dey without this one. So this one wey fit dey on im own without anybody, we dey call am independent variable. This one wey no dey fit stay on im own, we dey call am dependent variable, because im dey rely, im dey depend, im dey rest on another one. Without the other one, im no dey fit do anything. Now, if I use myself, before then, if you look this side, you go see say, after this other side, everything now, apart from the number then, you see say we write this variable now. Now, it's the one that wey dey inside, na im dey for this side. That one dey mean say, this f, say e dey rely on these other ones dem, na im be the meaning. Now, make I use myself, show example. Now, me wey dey for here, wey dey talk, my name na AMG, na im be my name. AMG, na im be my name. But see, me wey be AMG, I no go fit dey, I no be AMG. Now something they make me the answer AMG. Now wetin be that thing? That thing name na life. The life wey I get na im dey make me the answer AMG. So me wey dey wey my body wey dey for here, the answer AMG because of the life. Say AMG now is a function of life. Say me I dey rely on life. Meaning without life, AMG no dey anywhere. Without life, AMG no dey anywhere. Now make we look now. As I dey, comot life inside me. The next thing people talk now, they no go call me AMG. They go say where the dead body don dey na, where the body dey, the corpse where e dey. Na that kind of grammar they go dey talk. But because say I get life, now then they call me AMG. So AMG, the body wey dey here, say e dey rely on life. Now not only life I dey rely on. Now that life you go talk about me as even day dey break, as months dey go, as years dey go. Meaning that life, we talk about life again in terms of time again. So AMG, if you talk in terms of life and also time. So this my body, I dey rely on plenty things. So me now, I dey like this F, wey no fit dey on im own without life and time. Na so e be. So this one na so e be. So based on this explanation wey I bin dey give una, say e dey take value into this thing, e go come do some jiggy, e go come bring out another answer again. Make we try to see wetin we dey try to talk. Now this thing wey we dey see here now, na im be this relation wey dey for here. Now these x values dem, this one dem, na im be these ones dem. Now we wan take this one, put inside this box, make we see wetin e go bring out. Now see wetin I wan do now. This value dem, na I wan write now. This one na like this e dey. As I say, this one dem, the things dem wey dey inside there means this one -2 dey inside there, -1 dey inside there, 0 dey inside there, 1 and 2. All this one dey inside there. This one na the thing wey x fit take. X fit take this one, x fit take this one, x fit take this one. If you no like this one, x fit take this one. If you no like this one, x fit take this one. Now, make x take this one, then put inside here. As with them, x now put the first one into this place. Now, this one na im be that box. So see wetin we wan do now. Mathematics sweet o. Meaning say this other side, if x na im dey here, meaning say this other side wetin we get na this one. And this one we get am 2x plus 5 na im we get. Now see wetin we wan do. When x be -2, wetin come happen? When x be -2, wetin come happen? You go come see say in place of x here, where x be dey now, we don put -2. So meaning anywhere we see x now, we go dey do -2. Anywhere we see x, we go put -2. Meaning here 2 already dey for here. But for this place, because x dey, we go come put -2. You know say plus dey for here, we don put the plus back, then we don put 5. Now this one we get 2 times -2. The answer na -4. Then plus 5 na im dey for here. Now if you dey owe person 4 naira, you come get 5 naira. If you pay, wetin go be the answer? You go see say if you pay, you go still get 1 naira. Na im be answer. So you don see say when x take -2, you put inside the box, as you do jiggy, the answer wey come out na 1. You don see am na the thing wey dey talk. When x take im own value, put am inside the box, say e dey bring out something. Na im be the thing wey we don do now. Make x take -1 again, make we see wetin go happen. If meaning say anywhere x dey as we do for this one, anywhere x dey we don put -1. Here we get 2 -1 now, because we dey put anywhere we see x na we dey put -1 plus 5. Now wetin be the answer? 2 times -1, the answer na -2. Now plus dey for here, 5 dey. Now this one means you dey owe person 2 naira. Now plus 5 means you get 5 naira. And the law for mathematics say if you dey owe person, you go must pay. Even if the money no complete, pay the one wey dey on hand first. Now the law wey dey for mathematics. So now you dey owe person 2 naira, you can't get 5 naira. If you don't pay, wetin go be the answer? The answer go be 3 naira. And the 3 naira na money wey you get. Now im be this. Now make x take another number. Say make it be say x take 0. Say nothing. X now say nothing for x. Anywhere you see x, make we dey put nothing. Wey be the 0. Here x go there, so make we put nothing inside. Plus 5 is equal to 2 times 0. The answer na 0. Now, but you know say plus 5 still there. Now, you don't get anything. Now you can't get 5 naira. How much you get? You get 5 naira. Now the thing wey dey for here. Now, the other one wey dey again too, na e dey like that too. Make we see. When x take 1, wetin go come happen? When x come take 1 into the machine, you go come see say here go come get 2, 1 go come dey here, plus 5. 2 times 1 go give us 2. Then we get plus 5. So the answer go come become 7. You see as it be. Now, lastly, last, make we come do this one. This one na f. You go come, anywhere else you see x, we dey put 2. We dey say x don't take this one for here, 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 x don't take this one. Now for this one now, in place of x now we don't put 2, then we get 2 wey dey already, but where we see x now we don't put 2 again, plus 5. Now 2 times 2 will give you 4. But you know say plus 5 7. Now you get 4 naira, you can't get 5 naira. How much you can't get in total? Say na 9 naira. So you don't see say x now, the machine don't take x, this x number then into itself. But after you do small mathematics, you can see say you can bring out something. Now the thing we do. So this thing we do here na they call function. Now they call function. Now so it be. So if they take x into itself, you go come do shape body small, then you go come bring out another things then. Now this thing them sometimes they fit even resemble some of these things. But waiting you know say when the shaking body finish, in the end you know say you go bring out something. After all, when husband and wife marry, when una do finish, when una born begin, sometimes the begin feel resemble the papa. Exactly. No be so. Now so it be. Now so the function also be. Now see wetin dey now. This one now the one that we put inside the machine. As you come shake your body, come solve am, you can't get this one. So this one and this one, they very important. This one that they call them, this one the way we put, where the machine take first, they call them the input values. For English, they call them the domain of the value of the function. The domain. But this one where you come bring out, we call them output. Saying that the thing where you bring out output values. And another name we dey for these ones, they call them the range of the function. Make I come write am one kind so that we go really understand wetin I dey try to talk. On my way never write finish, make una no vex as I dey clean the board. Now, see wetin I dey try to talk now. These ones then are the one way the machine take put for your body. So we get them one na -2, one na -1, one na 0, one na 1, the other one na 2. And this one we say we call them input values. Input values. Or sometimes we call them x values. X values. But this one I say then guess name. The name where we call this one, we say the domain. This one, we call them the domain. So after now, I know they call them the input value or x values again. I will call them the domain of the function. Anytime when I talk about the domain, make you know say now the first thing is the way we put inside the machine, where the machine will come, the mathematics will come shape body, come bring answer. Those ones I mean they call the domain. Now the other one then, as we put, based on this relation where they here, where we get, the answer where we get now. The answer where we get now 1, 3, 5, 7, and 9. Now the thing where we get. Formally, I don't say this one we call them output values, or we call them f of x values. But this one, we know they call them output values or f of x values. But it gets name wey we dey call as this one we dey call am range, domain. This one then they call am range. The range of the function. So anytime they talk about the range, make you know say that they talk about those number dem wey after when they take the domain value into the machine, when you shape the body, the answer wey you get, na im we dey call the range. Now, this thing wey you dey see, meaning make you know based on wetin we do for here. You know say as we carry this one put for inside here, na im we get this one. As we carry this one put inside in place of x, na im we get this one. Meaning this one born this one, because of this one come out. 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 And because of this one come out. You see the way the thing dey. You see the way the thing dey. The way the thing dey now, the thing fine well well. Now this kind thing wey we see here, we dey call am say this thing na function o. Say this thing now, we dey call am, see the way wey you use rubbish, see the way you use mingle. For English, we dey call am associate. Say in dey associate, say in dey mingle with, in dey join body with the other one. Or sometimes we dey call am map. Mapped. Say the thing dey map the other one. No be map o, this one na map. We dey call am that is associated or say e dey mapped. We dey call it. But this one wey we see here, this thing wey we dey call here now, we dey call am relation. We dey call am relation. But the relation because relation na something wey when you don do, e dey get domain values and as a result of the domain value wey you put inside the thing, say e dey bring range value. When you see that kind of thing, make you know say that thing na relation. Now this relation wey we get here na function. This relation wey we get na function. Say this is a function. You know why we dey call am function? Say this relation na function. This relation na function because all the domain value wey you dey see here, all of them dey go out one. All of them dey go out one time. Na im the main thing. For it to be a function, all these domain side go out one time. So if you look this one now, you go see say dem dey go out one time. Na im make am say im be function o, because e dey go out one time to this other range side. Now, if you come look the range side, you go see say this domain one, as e go out, e meet another one. This domain, as e go out, you see say domain one no go two times to another one. You see say all of them get their own. All of them get them different. When e dey different like this, we dey call am one-to-one corresponding. That the thing na function o. The same time, say the way we use mingle, say na in a one-to-one correspondent. Say the way this one dey, we dey call am one-to-one correspondent. Say the way e dey call am one-to-one correspondent. Now, if you no wan call am one-to-one correspondent, we get a name wey we dey call am. When the thing be function, mean one go outside. Now this other side, you see say if they come bring out one thing, bring one more thing. You know one side from this side bring two things. No, all of them they get their own one. When you dey like that, we dey say the thing dey in one-to-one correspondent, or we dey call am say the thing dey be relation, say na injective function. Say the thing na injective function. Injective function. Say this function say na injective function, or you say the thing na injective mapping. Say the way you use me go say in dey injective. Either you say in dey one-to-one, or you say in dey injective. Now so that one dey. When you look at well, you go see say the thing really fine well. So this thing wey we dey talk now, na im be the function. So na all those things now wey I bin explain now. Now we don enter the mathematics small. Na im make I know say some people no go like am, but with the way wey I dey talk am now, una go dey enjoy am well. Now the way wey this one use dey, sef, I go do something wey una go come like well. Now look am now, I wan plot graph so that una go see. this one where we get here, this one where we get here, this one where we get here, this one where they say this function where they are, this one we don't say na function now. Now this function where they are, say we dey call them linear function. It be linear function because this other side, if you see now, for this side, the cap where you get for here, say only one. When the cap only one, say we dey the right hand. But if the cap na two, they go write two. If the cap na two, they go write two. If the cap na three, they go write three. If the cap na four, they go write four. For this upside, for this variable wey dey for here, wey they call x, no be for the number for this variable. But when it be one, we need a green right hand. When nothing, you don't see anything on top, no say the thing now one there. Now, when the biggest x, the x the way they, when the cap when we are, the biggest one now one, then they say that function say it is linear. So this one here now, how many x there? Only one x. Now, for the one x, how many cap in get? You see say that one get only one. So they say this kind of function, say we they call them linear function. Now, this kind of linear function, we get another name where we use call them. Say sometimes we call them line function. A line function. Say if you plot graph for this one, say what you will get now just one line, one straight line. Now you will get. So sometimes they call them line graph. Then they call them line graph. Now make we see what I try to talk. Now this side now you get 2, minus 2, minus 1, 0, 1 and 2. Which one big pass? This one ain't big pass. Now for this side you get 1, 3, 5 and 7 and 9. Which one big pass? 9 big pass. Now make we plot graph to see what I try to talk. Whether we will get only one straight line. Because I don't say this kind of thing is linear. So if you plot graph, say you will get one single line. Now make we try to plot graph, make we see. If we want plot graph, now so we the ruler. Now so we the ruler. Now for this side, you see say this side na the minus side, this side na the left side, this side na the right side, na the plus side. Now make we try to see. Make we try to see. From here to here, make I say na 1. From here to here, make I say na 2. But na the left side, na make I put the minus. From here to here, make I say na minus 3. Now from here to here, the way we did now, so you go also did this side. Only say this side na the right hand side. So on the right hand side na plus. So from here to here go be 2. Then from here to here go be 3. Now the same thing for up. This one na the x side. So this x things there, now I don't put for this side. You know, say we don't call them the domain already. Now, this other side, now the f of x side, which they call the range. The range will come there for this side. Meaning this one now we will call this one the f of x. This one are the f of x. Now, but the highest number, the biggest number waiting for here now 9. So I will do them. If I put 1, 2, 3 like this, you will see say the 9 will go up. So make I instead take 2, 4, 6. This one self, too close. Make I say 2, 4, 6, 8, 10. This kind of one. And this side will be minus 2, minus 4. That kind of thing. For this other side. This side na minus 2, this one na minus 4. We don't get minus for this side. If you look, all this one na plus number. So this side na it matter for us. Now, when it be minus 2, wetin e give us na 1. When it be minus 2 for here, wetin e give us na 1. For this side na 1. So 1 na somewhere here. If from here to here na 2, meaning 1 will be somewhere here. When it be 2. So this place here now we get. Then when it be minus 1, wetin we come get? We come get for the range side, we come get 3. When it be minus 1 here, the range side na 3. You know say here na 2, here na 4. So you go this center here, somewhere here. Somewhere here, because na minus 2. Minus 2 here, 3 here. Then when it be 0, wetin we get? 5. Here na it be the 0. When it be 0, what you will get? Say that 5, somewhere here. Then when it be 1, it be 7. When it be 1, this one is 1. When it be 1, say it be 7. Say you go there somewhere here. Now when it be 2, say it be 9. When it be 2 here, it be 9. So this one sef will come up somewhere here. So if you carry your ruler, come put am well well. If you use your normal paper wey dem dey use plot this graph, you come put your ruler, you go come see say, if you come put your ruler, you go come see say this line go just dey straight, e go just pass this one. And I make this one they call am a straight line graph, or they call am a line function. Say na one straight line na im go give you. Na this one they call. So when you see mathematics like this, we say this thing dey linear. Na so we dey talk am. And generally sometimes we dey write am like this. Generally sometimes we fit write am like this. The f of x is equal to mx plus c. Sometimes we dey write am like this. Now we have this m here now, dey like your 2. This your c, dey like your 5. Now the m here is the slope. The slope, and the c wey dey here na the point of intersection. Intersection on the y-axis. Na im be the c, the point of intersection. Where you cut the y-axis, this f of x-axis, na im be this one, na im be the c. And the c say where you cut am na the 5. Na so e be. Na so this thing be. So this one wey we dey see here, we dey call am line graph. This one na the equation of the line. General equation of the line. Where c go fit take any number, this m sef go fit be any number. Now that we don learn this one, I wan make we look another area wey go do us good. Wey go do us good. If the way I do the other one, if I come say make we look another function. If I say make we look another function, now this one now the function f of x is equal to x raised to the power 2 plus 1, where x is contained in minus 2, 2. So this one self, I don't say this one and be the relation where we get, and x they take minus 2, 1, 0, 1, and 2. Then make we try to solve wetin we been do for the other one where we be the draw one table. Now, as I don already do before, you know say the x number dem wey we get, wey dem dey call value, the x value dem wey we get na minus 2, minus 1, 0, 1, and 2. Na im we get. Now for this other side, this one na im be the function wey we get. This one go come dey this for here. Now wetin we dey mean here now say when x take 2, carry 2 put inside the machine, wetin e go bring out? Wetin e go bring out? Now if x takes 2, meaning anywhere you see x for this side, you go come put minus 2. Then where you get x squared, so you say minus 2 squared, because after all, anywhere we see x na minus 2 we dey put. Then plus 1. Now if you solve this one, you go see say this one means minus 2. This thing wey dey inside dey times itself 2 times. The times itself. So minus 2 times minus 2, the answer go be 4. The answer go be 4. Then plus 1 dey. Now if you add 1 and 2, the answer go be, 4 and 1, the answer will be 5. Now the other one, make we look this one again too. If x now take minus 1, meaning anywhere we see x for this side, we put minus 1. If you do so, you go put minus 1 then square plus 1. Now this one means, as I talk for this one means minus 1 times minus 1. And the answer will be 1 plus 1, this side 1. And if you add the 2, you go come get 2. 1 plus 1, the answer will be 2. Now, if x take 0, anywhere you see x, say make you put 0. Meaning here, x there, so we don't put 0. Then 1. 0 times 0, the answer is 0. Plus 1. So we get 0 plus 1, and the answer will be 1. Now, the other one we get again, now this kind of thing. We don't put 1 as we dey do. For this other side too, we go put 1. We go put square here plus 1. Then 1 times 1, the answer na 1. plus 1 dey here. If you put 1 plus 1 here, the answer will be 2. Then last, make we come do this other one. Anywhere we see x, we will come put 2. Then here x na dey, so we go put 2. Then square plus 1. 2 times 2 here will give you 4 plus this one wey dey here, so that this one will give you 5. See wetin don happen. As we put this one now na the machine, na the relation. As we put the x value, the domain value inside the machine, e come bring out this other side wey we dey call the range value. This other side wey we dey call the range value, na im that one come bring. So with this one, make we still do like the other one wey we come put am for small second to really see wetin the thing bring. Like the thing wey I bin dey talk now, see wetin I dey try to talk now. Wey I say this side na say na the domain. The domain we get -2, -1, 0, 1, and 2. Na the things wey we get. This one I say na the domain. Then wetin come bring wey we have the range side. The range side we get 5, 2, 1, 2 and 5. But we no go rewrite those 2 and 5 again because already 2 and 5 dey for here. So this one now we get, say this one na our range. This one na our range value. But see wetin happen now. When we be put 2 into the machine, wetin come into the relation, e bring out 5. When we put 1, wetin come happen? E bring -1, e bring out 2. When we put 0, e give us 1. When we put 1, e give us 2. When we put 2, e give us 3. Now look at this one. If you now look this one, you go see say this one no dey like the first one wey we bin do. This first one wey we bin do, the first one give us im own, this one give us im own, this one give us im own, this one give us. Now so all of them give their own separate. But for this one, if you look now, you see that this one and this one, they give us the same thing. This one and this one, they give us only this one own separate. Now this kind of thing now, make we look whether this one wey they call relation, this one na function. Now function, yes, this one na relation, say that they associate, that they mean what? Yes. But say the thing whether na function, yes, if you look this one, the thing na function. This is a function. This is a function. Say this one na function. Na function because all these ones that wey dey here you see now, all of them they go out one time. I say for it to be function, all of them they go out one time, they go mingle, they go out one time. You see all of them they go one thing no go 2 times. If one thing go 2 times, now you say the thing no be function. But for him to be function, the thing must go out. So you see say all of them they go out one time. So the thing na function. Now, which type of function be this? Now, if you look this, the other one we talk, where we say na 1-to-1 corresponding, say the thing na injective mapping. If you look that one now, this one and that one no be the same. That one, all of them, they come 1, 1, 1, 1. But this one, yes, all the things where they inside, something touch them, something they bring to them, something they go touch them, arrow they go touch them. But then you see say 1, 2 things they from this side, they come touch only one thing. Now when it don't be like that, provided say all the things where they inside, something, I will go touch all of them. Say this type of thing we they call an surjective mapping. Say the thing na function, yes, because of this side, the way you use go out. Then for this other side, this one will be injective, this one will be 1-to-1, but this one we they call an surjective. Surjective mapping. Surjective mapping. Say na so this one come be. This one too is fit also plot a graph. If you plot graph, you go see the way this one come be. Now make we look at another example where this time around I no go put I no go do this table side, but make I just only dey write this other relation side so that we go see, so that make we dey do the thing then sharp dey go. Make I no do this other side already. We don't understand say now from this side, this kind of thing, now in that side come out. So make I know they come, they write this side. Make I instead just concentrate on the other side to see how the thing they be. Now, already the x side, you don't say that one and the domain. The domain, make we call this domain, make we call this one three, the things that we dey inside 3, 4, and 5. 3, 4, and 5. Now make we get another one wey be 8, 9, 6, and 7. This one now, as we know, this one then they call am the range. We dey call this one the range. Now see the way wey this one use mingle. This 3 come to this 6, this 5 come to this 7, then this 4 go to this 8. Now if you look at this one, now if person wan ask you this thing wey dey here, the relation wey dey for here, na the relation because of the way in dey mingle. Yes, in dey mingle well well, so na relation. Now this relation wey dey here now, na which type of relation? For the things wey we don learn, na injective one or na surjective. Now if you look well, first of all, for them to be injective or surjective, the thing must become function first. Now for it to become function, this side wey we dey call the domain side must go out, the arrow must go out one time in each of the elements wey dey inside. Now if you look, 10 self go out one time, 4 self go out one time, 5 self go out one time. Meaning say this one na function. This one na function. Now this other side make you look am. Now when you look, you go see say this one na dey come to 1, this one dey come to 1, this one dey come to, but e get only one, no 2 1 come to from this side, come to this other one like this other one wey we get. All these one dey come one like the first one wey we bin get. Only say one of them wey dey inside something no touch am. Now I dey say this one wey dey inside, being say all this other side, the range side, dem touch dem one time, no be 2 times, one time, we dey say this one sef na 1 to 1. This one sef na 1 to 1 correspondence or 1 to 1 mapping. 1 to 1 mapping, or you say injective. The injective mapping, or you say na injective mapping. Yes, one of them dey wey something no touch, but the main concern na the way wey dem use mingle. You see say na 1 to 1. This one e get im own, this one get im own. No 2 from this side dey go to 1 like this one dey. You see say this one sef go to this one sef go to this one. While this other one e dey 1 like the first one wey we bin do. So this one sef dem dey call injective, or you say 1 to 1 mapping. Now make we consider another case to make sure say we really understand wetin we dey do. Make we really consider another case so that we go really understand wetin we dey do. If we get for this side, say if we get 0, 1, and 5 for this side. Now for this side we come get 0, 2, 10, and 6. Look this side wey we dey get. Now if this one come mingle with this one, associate with this one, only this one sef come here, this one come here, this one come here. See the way this one come be. See the way this one come be. Now the first question now, this one na relation. Na relation? Yes, na relation. Na relation. Na im make this one don come out. But this type of relation wey we get, na injective or na surjective? Na im be the question wey we dey try to ask now. Now, first of all, for them to be injective or surjective, the thing na function. The first thing na relation, yes, na relation. But the relation wey dey now, na function e be. We don say for it to be function, say the thing the way dey the domain must go out one time. But if you look this side, you see say this first element wey dey here, only him go out 2 times. For the sake say only that one don go 2 times, the thing no be function. For us to talk about injective and surjective, the thing must become function first. But this one already, it no be function because the thing go out 2 times. So we are going to say this one is not a function. This one, it no be function. The criteria wey dey make things to become function, if this one no reach. So being say no become function, we no go fit talk whether e dey injective or surjective, because the thing must become function first before we talk about injective or surjective. Make I talk another one, make I do another one briefly so that we go dey understand the thing dem small small, kawakawaya dey go. Na similar thing na how dey bring o, but make I dey bring another one, another example so that we go understand wetin we dey try to talk. Now, see this one wey I wan write. So this one I put A, B, and C. This one are the domain values dem. Then for the range values, make I say I get 2, 3, and 4. Now see the way wey dem use mingle. A come to 2, A come to 3, B come to 4, and C come to this. See the way this one come use mingle. Now, this one now, na relation, yes. But the thing na function. For us to talk about injective and surjective, I don say the thing must become function first. Now, this thing na function. If you look well, this down, e go out. I say for it to become function, remember, say the thing dem, the arrow must go out only one time from the domain. Now, this down, you see say e go out one time, this one go out one time, but this one, if you look, now 2, it go out 2 times. Being say go out 2 times, we dey say this one no be function. So it no be function, so we know if we talk about whether it be injective or surjective. Now make I come put one other one so that we will really understand them well. I will do 2 more so that we will really understand that well. Make we dey go. The one I want to talk about dey similar to that one. A, B, C. This one are the domain side. Then this one, if I can say this one are 10, this one are 20 here. 2 elements here. We have this one, they come here. This one, they come here. This one, they come here. This thing make we look whether this one na function. Class, this one na function. For it to be, yes, it's na relation first, but is it a function? This relation wey dey here na function because if you see the domain side, all of them go out one time. Now, this other side, what is going on? You see, say, this other side, all of them, them touch them. All of them, they touch, none of them remain. But the way we use touch, no be say, them touch one on his own. No. 2 from this side, though they go out one, but 2 from this side, they come touch this one. So this one, and we don't do similar thing before. This type, we dey call this one surjective. Being say all of them will be inside here for the range side. Sorry. For the range, all of them touch, all of them, no one remain. They call this one surjective. Surjective mapping. Surjective mapping for this one. Now, lastly, make I come write the same thing. Lastly, make I come write this one. Then I will come make one big grammar so that we will really get wetin I dey talk. Now, see this one. See this one. This one come here, this one come here, this one come here. Now, make you see this thing before I make the grammar. Now, this one na relation. Now, this relation na function. E be. Yes, na function e be. Because all these ones, the domain value, them, all of them go out one time. All of them go out one time. So na function. But which kind of function? See the way that they use mingle. You see, say this one, go to this one, and I see don't go another one, no touch them again. This one said go in your own separate, this one said go in your own separate. So this one then resemble the first one we do, where we say this one na 1-to-1. Now, for something to be in a surjective, already this one don't be injective. But we don't say for something to be surjective. Say this range value, all of them, something we must touch them. All of them. Now if you look now, you see say true, all of them, something touch them. So this one, where we do here now, in the injective, the same time in the surjective. Now function, this is a function. This is a function. And the thing dey injective, the same time e dey surjective. Now we dey say now say if something dey injective, The same time that thing dey surjective, say that thing we dey call am bijective. If a function is injective and the same time surjective, then that function is bijective. If that thing be injective, only him come be surjective, we dey say that thing na bijective. Make una see wetin we don learn. We don learn plenty things for here o. Now, you don see say, I don say for us to really learn wetin dem dey call calculus, say small things dem dey inside wey we go learn. Now, those things dem wey we dey learn, one na injective. We don say a function dey injective if the domain values, all of them, go out one time, go reach the range value, then touch them one time, then that kind of thing dey injective. Now, e dey surjective if the range values, all of them, something touch them. But remember, for something to be injective or surjective, make sure say the thing become function first. Now, the statement wey I dey try to make here now, some relation wey dey, all relation, make I talk am like that. All function, anything wey be function na relation. All functions are relations, but not all relations are functions. All function, for you to be a function, say mean it must be a relation first. So all functions are relations, but not all relations are functions. Already, we don already show am with some examples. We don already show am with some examples. So na so the thing be. Now the thing wey I wan talk again, there is a way wey we dey get one way, some ways wey we dey use write this thing dem. Sometimes when some people see am, dem no go like am or dem no go really understand wetin we dey write because of the way wey I don write this one before. Now see wetin I dey try to write. Now if we get -2, 2 like this, then I come get -1, 4, I come get 0, 1, I come get 1, 3, I come get 2, 4. This kind of way, dem come tell you say, is this a relation? If you look am, this thing now resemble those things wey we don do before. But if you don't know, you no go know. Now see wetin dey. This one now wey dey here now, dey tell us. Then they now tell us say, this is a relation? Because we don say a relation na something wey get business to do with domain value and range value. That kind of thing na relation. E get a pair. The pair na one, the range value and the domain value. Now this one wey you dey see here, we dey call am pair. We dey call them pair. We dey call them pair. Now, inside this pair, we get domain value. We also get range value. Now, these first ones that we dey, this one na be the domain value them. So when you see them anywhere like this, make you know say those things na pair, but it's made up of the domain and the range value. So based on wetin I don explain here now, which one be our domain value? You go see our domain value wey dey here na -2, because na the first one. Here na -1, here na 0, here na 1, and there na 2. So the domain values for this pair, for this relation wey we get, na dem be this. Now, if na so e be, then the range value dem go be the last one. This last one dem, na dem be the range value. The range value here go, so e go become 2, 4, 1, 3, and 4. We no go write the 4 again because already 4 dey inside here. 4 dey inside here. Now see wetin I don do. This one come to here. Now so e be for here. -1 and 4. -1 and 4. This one 0 and 1 come here. This one 1 and 3 come here. the last one 2 and 4 again. Now this other one, now first one, is it a relation? Yes, it's a relation. Now is it a function? Yes, it's a function because if you look at the domain value, all of them go out one time, so it's a function. This is a function. This one a function. Now, but what type of function? Is it injective? Is it injective, or is surjective, or is bijective? Those three things we don't learn. Remember, I don't say if something is injective and at the same time surjective, say that thing na bijective. Now, make we look. This is a function here. But for this other side, if you look now, this one come one time. But this one now, two things now you come to this one. So already for injective side, they don't fail. And being saying the thing don't fail for injective side, it no go fit become bijective too. But rather, the other criteria now, all of them something touch them. Yes, all of them something. So this one we will get now surjective mapping. This one now surjective mapping. This one now surjective mapping. This kind of thing, you see the thing now, they really make sense. But it make I write some things them small, so that we will really understand wetin dey go. You know, say the first one wey we do, I try to plot graph. Now make I write some. I want to make the people wey dey this class make we dey try plot this thing, do this thing the way I dey do, and try to see whether I go fit plot graph. Make we see the shape, the way those graphs dem go be. Like the first one wey I do now, the linear function, I say na straight line graph. Now this one the way I wan give now, make we know make una tell us which kind of graph dem go give us. Which kind of graph dem go give us. And at the same time, make una also tell us which kind of function. Is it and which type of if there be function, first of all, if there be function, or if there be function, then are they injective, there be injective mapping, or surjective mapping, or bijective? Make una tell us all those ones. Now, wetin I wan give una now, I dey say make you determine the shape of the following relation. 1. This one already I don solve am, but make I just give am again so that make una no think say na new thing. Where the domain two, make we do this one. This kind of one, where the x values dey inside this range. Then 3, where the x values now e dey inside this range. Then make we consider another one, say 4. Where theta dey inside this one. Then lastly, say 5, where we dey talk about the square root of x, where we say x dey inside this one. Now, these things the way I don write, I want make we tell us if there be function, first of all. All these ones are relations. Now, this relation, there be function. If there be function, which type of mapping there be? Meaning, remember say, all these ones then are the domain there. You go come find the range. then tell us how they use whether they be injective, whether they be surjective, whether they be bijective. And I go tell us that one. Then, and I go come plot the graph the way I do for the linear one. Make we see whether this is them. The graph them, all of them, whether na linear or na different shape, whether na in them go, whether na different shape, na in them go take. So now this one now I don't give on. Now make I will try to stop here for this one. But before I stop, remember, say the new class wey we dey start now, we don't give am name, code. Now they call am the code wey we give am na mass 102. Now for inside the mass 102, wetin we wan learn say na calculus. Now don't tell una say calculus for us to really learn calculus, plenty things wey we go touch, wey we go really understand the calculus dey. But the calculus na more of na differentiation and integration. But for us to learn those things, now we start this morning, begin to talk about wetin functions dem be. Now inside function, we don't say a relation dey. A function na something wey dey somewhere, wey go take in x values, where the x values wey dey take, we don't say them, they call them domain values dem. To itself, e go come process them, e go come bring them. The bringing out of them, we call them the attribute values. Those attribute values, another name we dey use call them na the range value. So it will take in, they will take the domain value into their self, then they will come bring out the range value. Now we come try to also know if the thing na function. Yes, if the relation wey we don see now na function, why I come be a function? We don't say the domain value them when then they go out, we go make sure say all of them go out one time. No one variable or value in the domain must map out 2 times. If you do like that, then that thing will be function. So a relation can be a function can be a relation, but a relation must not be a function. And that thing dey. So if you dey like that, then it will be function. Now, if the thing na function, we can look which type of function, mapping, association, which way we use mingle. The way we use mingle self matter. Either it be injective, surjective, or bijective. For it to be injective means as they go out, all of them will go out one time. Now for surjective, all the range values, all of them, something must touch them, even if they don't go out one time. Now for the bijective, we don't say the condition for the injective self go dey, then for that of surjective, then you go now say that's in a bijective function. And finally, I don't give a small, all these ones wey dey here, we call them relation. They na small mathematical formula there. Where this side wey dey here already na the domain, the x values them, the input values them, na them be this. Take them, put inside this machine, make you see how it will be. Lastly, remember, I use myself, give example. Me wey dey here self na function. Because as I dey here, I know if you stand on my own. Say me, they rely on something. Now me wey dey here, myself, my name now for mathematics na dependent variable, na it be my name. Then the thing where I dey rely on, wetin I dey rely on na life. Now life where I dey rely on, we dey call am independent variable. But life fit dey on its own independently. But without life, me, I no go fit dey. So me now, I am a function of life. Na so the mathematics dey. You know, sweet or not? Tomorrow, na another day, and I will enjoy more. Thank you very much.